Hi everyone, here we are in week 2 of our digital image processing class. This week we have 2 new topics. One is we're looking at the differences between aerial imagery and satellite imagery. And in the second lecture we are looking at some of the characteristics of remotely sensed images. So this first lecture I really enjoy because in college, in grad school, I actually took a course on air photo interpretation where we didn't use computers and we basically looked at hard copies of aerial photos, and we learned how to do things like calculate the height of the Eiffel Tower based on shadows, orthorectify images, all sorts of really hands-on fun analysis, learning formulas for figuring out the height of buildings, the volume of a lake, things like that. Measuring parallax. Anyway, it was a really fun course, so we don't get, unfortunately, as much time as we could have to dig into how to actually analyze air photos. But we are, in this lecture, taking a look at the differences and the similarities between aerial photos, or photos taken by a plane or by a balloon or by your drone, and satellite images, which are in the Earth's atmosphere on space satellites. So what I'd like you to focus on in this lecture are the similarities and differences in the actual product that the different collection methods create. Things like the different bands that are available, the type of imagery that's available, the data that's available. Can you get a digital image from an air photo? What's the differences there? Oh, and then also both sets of images, whether it's from an aerial flight plan or a satellite remote sensor, have some sort of distortion in. And we talk a lot about distortion in GIS, about how we distort the 3D nature of the globe onto a 2D piece of paper computer screen. Same thing happens with our remotely sensed images. So we'll look a little bit about the different types of distortion within each collection method and the different methods to adjust distortion. And we'll get more into distortion in a couple weeks, but get some ideas about orthorectifying and other correction methods. What else? The second lecture is on the characteristics of remotely sensed images. So this is a great refresher on how to actually do image interpretation. So we'll look at things like the different characteristics like size, shape, shadow, tone and color, texture, pattern, site association. So when you look at an image, you can use these 1, 2, 3, 4, 5, 6, like 8 or so characteristics to figure out what is actually going on in the image, what you're looking at, where you might be looking at, what season it is. So when next time you're in an airplane and you're flying over the land, you can look down and start to understand what you're seeing below you. And then we get into a little bit about image quality. So not just interpreting your image, but understanding how the quality of your image will impact your ability to do your interpretation, but also impacts the data and the analysis that you can do. So if you've ever wondered the difference between a 4-bit and an 8-bit image, we are going to get into that in this lecture. Your image quality, like I mentioned, impacts your data. So pay attention to how it impacts things like, or how high resolution, high bandwidth, high bit number will impact your file types, how this will make your files, your remote sensing image files, a lot larger, and therefore impact your processing time to come up with your results. So all things to be concerned about when you are working with your remotely sensed images. So it's a fun week of learning a little bit more about imagery and doing some interpretation. This week, remember, you have a discussion assignment, and your at-home assignment is one of the web courses online. If you have any questions, let me know. Remember, we are not meeting this week. Have a great week.